We're live. Well, now we're live. I'm doing this live where it's a bit of a test thing, trying stuff out with StreamYard. If you're watching this in the replay, which chances are you are, I'll link some things in the description so you can head right to the parts that you might find most relevant. What we're looking at is Calculus Made Easy, Chapter 13, Useful Dodges, partial fractions, not partial derivatives, partial fractions. And the idea is that if we do a little bit of pre-processing, it makes the derivative a little bit easier to work with. And so as an example, we'll use a fairly straightforward rational expression. I'll bring that up right now here. Okay, you should be able to see that okay. And let me just go over here. So here we go. So we're doing d by dx of 3x plus 1 all over x squared minus 1. And if you're watching this live, do let me know that you're here, and so I can say hi to you. Okay, pretty cool. So let's see. Okay, now over here on the screen, I've got my cheat for the quotient rule, because the quotient rule, there isn't a lot in mathematics that is pure evil, but I think the quotient rule comes pretty cool because I need a cheat for it. Maybe one day I'll get it without a cheat. But anyway, there's your quotient rule. So first of all, we're going to differentiate this function with just using the quotient rule. We're going to use quotient rule both times so we can compare fairly. Then we'll pre-process with some partial fractions and try it again. And you decide what you think is the does it make it easier or not. So let's fly at it. Okay. And if you can't hear me and you're watching this, let me know, because I'm experimenting also with technical stuff here. Okay, so quotient rule. So this top thing, that's our u. This bottom thing, that's our v. So v squared. What's v squared going to be? That's going to end up being so it's d by. Okay, so d by dx is going to end up being. We'll put v squared all in the bottom. It's going to be this thing all squared. Okay, which has got x squared squared minus 1 squared, so that's going to be plus 1, and then minus 1 times x squared, but double that, so minus 2x squared. Batman. Fair enough. Okay, now we've got v u prime and then u v prime, but it's important to get that in the right direction because there's a minus sign. Not like product rule. So what's our v? V is x squared minus 1. So we'll put in the x squared minus 1, put that in parentheses. And then u prime, that's going to be 3. Instead of putting it after, I'll put it before. So that's my u prime v minus u v prime. So let's put the v prime first. So v prime u, so let's put it in that direction. V prime is, there's v, so that's 2x. And multiply that by u, and where's u? U is 3x plus 1. Okay, calculus complete. Now let's do a little bit of algebra. Let's see, equals, all that's over x to the 4th minus 2x squared plus 1. And what do we got on top here? 3x squared minus 3 minus 6x squared minus 2x. Okay, and then this on top, we'll simplify that somewhat to minus 3x squared minus 2x minus 3. That's a bunch of minuses, so let's just do this. X to the fourth minus 2x squared plus 1. Bob's your uncle. We should check to see if that's right, because when I did the prep, I didn't go all the way through. I'll check later. Let's do this. Let's do this. Let's go into let's go into Desmos. So hang on. Nah, I'll do it. No, do another time. Let's not improv. Now we will break it down into partial fractions. So that was part A. Now for part B. Okay. Same question. D by dx. 3x plus 1 x squared minus 1. Okay, and again, well, we'll get to our cheat in a moment here. What we're going to do now is I'm going to skip the d by dx. I'm just going to do a little bit of what I like to call pre-processing here. X squared minus 1. Okay, and that equals, I'm going to factor out the bottom bit. So x plus 1, x minus 1. And just 3x plus 1 on top. Okay, and I'm going to make that equal to each factor is going to become, hello. Looks like there's two names here, Brian Stalin Almendarez Suarez. Good night and good evening. Thank you for your greeting. So I'm just going to say A up here and B over here. And there's a whole lot more. I mean, this is an example. There's a whole lot more to partial fractions, but I thought I'd start with an example that goes into it in depth in the textbook. We've got x plus 1 here, x minus 1 here. And so now we need to figure out what A and B are. All right, so how do we do that? Well, let's take a look here. We know if we were to add these together, we'd have to have that common denominator. So we'd have x plus 1 down here times the common denominator is just going to be the product, which is going to end up being x squared minus 1. So this A has to be multiplied by x minus 1 for this to work. Okay, plus B all over x minus 1. But we're going to multiply the top and the bottom by x plus 1 for this to work. X plus 1. All right, so what does this end up being? Well, this ends up being ax minus a, and this ends up being bx plus b. Hey, good morning. Good morning. Muhammad Akmal. Oh my goodness, Quarunas. Now, if you're saying good morning, I suspect you're on the other side of the planet from where I am. I know in India, I got a lot of viewers in India, and it's about 12 hours difference. So it's cool that I got people watching. Alrighty, so let's keep rolling. How's the sound? Sound okay, gang? What do we got here? So we've got ax minus a all over all of this business. X plus 1, x minus 1, And then look at this. I can do this because we're adding it together, right? Plus bx plus b, and it's all over x squared Indonesia. Okay, okay, you got this. Yes, yes. Did you see Black Pen Red Pen posted a really funny outtake? I love this guy because he can laugh at himself. Did you see his thing? It was about a minute long, where he about 13 times he tries to finish this one spot and make it sound good. And I figure I really respect this guy because I know what it's like, you know, to just try to do this stuff live without editing. If you haven't seen that, check it out. I've got a link to it in the community section of my Facebook, not Facebook, my YouTube thing. All right, so remember, what did all this equal to? All that equaled 3x plus 1 over, and then remember, we multiply that out. It's just x squared. I don't even need the parentheses. X squared minus 1. Okay, so let's rearrange this. The ax plus bx, ax plus bx, that is going to be your 3x. And your minus a, I'm going to leave the minus here so the a's are above each other. The minus a plus b, that's going to be the 1. So we'll put there 1. Okay. Now let's cancel out these x's. So what we have is a plus b. A plus b equals 3. Negative a plus b equals 1. So let's just sum up these two equations. 3 plus 1 is 4. Minus the a's cancel out, okay? And so we end up with 2b equals 4. So b equals 2, which means that if b equals 2, then b equals 2, then a has to equal 1, okay? A equals 1. That looks good. That looks good. Okay. We're good. My notes are extremely messy. I may end up regretting this. Okay, so let's go back to this. Do I have everything right? Ax minus a plus bx plus b, 3x plus 1. Just afraid I'm going to end up with something different. Okay, no, we're good. We're good. Okay. So now let's rewrite this expression, our original expression, and I'll write it again here so we can see it. Okay. And remember, we've just broken this up into partial fractions. So we've got 3x plus 1 equals x squared minus 1 equals, and then remember we had a over x plus 1 plus b over x minus 1. That was over here before we did. Oh, here it is, right here. Okay, so now let's replace a and b with their appropriate things. So we got 1 over x plus 1, and then b is 2. Okay, and so this science method to solve differential equations for partial fractions. I didn't know it's using differentiation. It's great to learn something new every day. You know, I'm going to tell you something. I've only seen this like in my doing stuff. I see this for integration, because integration needs all the help it can get. I have not. Yeah, I'm not used to doing this for differentiation. This fella, the textbook that I'm getting this from, he does things quite differently than you would do it nowadays. And in some ways, it's new and fresh. In other ways, in other times he's assuming that we have a certain knowledge that we don't necessarily have, and that's like with the the binomial theorem. I think everybody like 100 years ago knew the binomial theorem, but I don't think it's taught as much. It's expected as much this time. So I mean, if you're familiar with integration, you don't want to integrate that first thing. You don't want to integrate this 3x plus 1 all over such and such, but you're just laughing when we do integration. You'll just be looking at these and going, oh, this is about the easiest thing in the world. Here, you might not think we're saving a whole lot of time for differentiation. So now let's find the derivative of these things, okay? So remember, we're actually interested in d by dx of all that. So that's going to be d by dx of this plus d by dx of this. Okay, so again, quotient rule, v prime u, I'm doing this even without looking. I look over here, minus u prime v, I think, over v squared. Oh, yikes, I should remember this. Okay, so top is u and bottom is v. All right, so now v squared. I'm not even going to write that. I'm just going to get rid of that. Okay, so I'm going to square, for this first one, I'm going to square the bottom. So that's going to be x squared plus 2x plus 1. Okay, and then now I need v times u. Okay, well, what's u? Well, u is just 1. Sorry, v prime times u. So what's v prime? Well, that's the derivative of x plus 1 is just 1. Okay, and then that's going to be times u, which is, I'll put the 1 here, so we got v prime times u minus u prime times v. So u prime is, well, that's just going to be 0. 0 times x plus 1. Okay. So this partial fraction, when we take its derivative, it ends up being the reciprocal of, or 1 over x squared plus 2x minus 1. And then now we've got this one that we've got to do. So that's going to again be v squared down on the bottom is going to be x squared plus 1 minus 2x. Okay. And then up here we've got v prime. Well, that's just going to be 1 times u. Okay, this time it's times 2. Okay, this is going to be plus. Okay, minus, what is it? U prime? Oh, again, we just got 0 times 1. Okay, so the u prime is nuts. It's easy because it's just a constant. So we end up with 1. Okay, plus 1 over x squared, and is this what I end up with? It looks like it. I hope so. I thought I had all the notes here. Hang on here. 1 plus x squared. You know, I think I've made perfect notes, and then I look at what I've brought, and I go, oh, I'm missing stuff. That should be a plus 1, and that should be a plus 1. And this should be 2. And this, I believe, is your whole derivative. And unfortunately, you know what? I went and I closed all my tabs. I had checked this earlier on Desmos. Let's go look. Let's go look and let's just see how much I've messed up, because I've done a lot of this. I've done a lot of the thinking live, and I don't know why I do this to myself. So I'm going to bring up Desmos. So if you want to stick around while I check this and laugh at me if I'm wrong, you can enjoy this. Because you might be the only people seeing this, because if this is really bad, I may not keep it. All right, so I'm going to bring up Desmos, so hang on, and then I'll let you guys see what I'm doing here. So what time is it where people are at? Tell me the time. Okay, we're going to share Desmos with you here. Share, stop screen. There's me. Okay, and now I'm going to share Chrome tab, Desmos graphing calculator. Should be able to see that. Yeah, okay, so that's up. That's up. All right, so this is just going to be a little check. Okay, so we've got x squared plus 2x plus 1, x squared minus 2x plus 1. Okay. Okay, so we've got 1 over x squared plus 2x plus 1. Okay, minus, it just feels different from when I checked this earlier, plus 2 over x squared minus 2x plus 1. Oops. Okay, that looks okay. All right, so this is what my partial fractions thing looks like. My solution that I got for the derivative by partial fractions. Now, I've got a different form of a solution. I'm just scrolling here and I'm going to find it and I'll bring it up and I'll write it in for you. Okay, minus 3x squared plus 2x plus 3. Yeah. Minus 3x squared plus 2x. And then, I gotta check here. 2x plus 3. Okay. And divided by x to the 4th minus 2x squared plus 1. X to the 4th minus 2x squared. See if I can keep this in my head. Plus 1. Plus 1. Ah! Yeah, I thought that there was something about a minus sign that I messed up here. What happened if I take away this minus sign? Yeah, okay, so one of these is right, and one of them is wrong. I'm having a great day. Yeah, I want to check the graphics good. Okay, this isn't so bad because what this means is I messed up. Can you see can anybody tell me what I did wrong here? Because this is a keeper. We're going to keep this because it's just a minus sign is wrong. You notice we've got these two forms. What did I do wrong with the minus sign? Anybody have any notion? We'll have to check that later. But what I think that I guess this minus sign is wrong here, or I've messed up somewhere along the line here. I made one negative when it should be positive. I don't know. Okay, so the idea is that we both get the same solution theoretically, except one of them is wrong because it's negative. You might go, okay, but which one of these is right? I mean, which form do we want? And it comes down to who cares? It depends on what you're after. I mean, let's check. You know how we can check to see which one's right? We'll do d by dx. I love Desmos just for checking these things. And what do we got here? On top, I've got 3x plus 1 over x squared minus 1. Okay, so there you go. So it's actually this one. This one was right. The blue one. So this one without the negative sign, with the negative sign is correct. Somewhere, the one where I did with the partial fractions, I should put in a negative and I didn't, and that must be. Let's go back. Let's go back and fix this before we go. We're going to make this right. I know signs. Yeah. Okay, I'm going to keep this because I want you guys to see that you got to see what it really like live when it's not all nice and put together. We've got to keep this for posterity. So let's go over, and then you guys can do timestamps. All right. So I'm gonna go back and share the whiteboard here. So share, stop screen. Let's go back now that we know which one's right and what we're trying to get. Share screen, and Chrome tab, and whiteboard. Okay, so which one was right? This one was right, wasn't it? With the negative sign. So somewhere I made a mistake, with the negatives here. So what did I do wrong? 3x plus 1, 3x, okay, x plus 1, x minus 1. Okay, so that's ax minus a, and that's bx plus b. So that should be ax minus a plus bx plus b. A plus bx equals 3x. 2b equals 4, b equals 2, a equals 1. So d by dx, well, it must have been when I was differentiating. Did I get this right? V prime u minus u prime v? Is that right? Or did I mess up with the quotient rule? The evil quotient rule. Okay, so you see what I did here? I got my minuses because I hate quotient rule. In any world, what I would do is not use the quotient rule. I would just convert that to product rule with a negative exponent on the bottom, because that's exactly it. I was so proud when I was doing that, and somebody was going to watch this and cringe and see me doing this. V prime u, u prime v. That should be vu prime, uv prime. And so because of that, I have got the sign reversed up here. And so that is going to reverse the sign of my final solution. And so let's just fix this the way. So minus so many points for me. So that should be plus. That should be minus. Is that right? Vu prime. Anyway, and then if that's the case, then this everything ends up being negative. That's negative, and that's negative, and so we get a negative solution. I'm gonna go have dinner or something. What is it? I guess you folks halfway across the planet, Tuesday morning for you? Off to work, off to school? What's happening? What's happening before I go? Tell me what you're all doing. And we'll do, hang on here. Got to remove, stop the screen. Okay, so yeah, sign can make us angry. So what's everybody doing today? School, work, more math just for fun? I'm gonna go have dinner. It's about 5:45 here. Hang out, watch some TV with the spouse, and get some rest because I need rest. So cool gig. Soren Bosel, hey man, hope you're having a good day so far. What's going on here? I use Desmos. Yeah, awesome. Cool. Anyway, go to the community tab. My community tab, check out Black Pen Red Pen's. There's a link there to Black Pen Red Pen's funny video that he posted this morning. And have a great Tuesday, gang, and we'll talk to you again. Bye-bye.